Suppose we try to expand a plus b to the power of 1. We know that we are just going to get a plus b. Now a plus b squared is equal to a squared plus 2ab plus b squared. And a plus b whole cubed is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. Now the binomial theorem shows us a way by which we can find a plus b or any two terms to the power of any number. So now we shall first see the coefficients here and see whether they form a pattern. We study the coefficients before we study the binomial theorem. Now these coefficients are called the binomial coefficients. So if you look at these two coefficients, we have 1 and 1. Here we have 1, 2, 1. 1, 3, 3, 1. Also you can see that a cubed becomes a squared, becomes a to the power 0, which is 1. And b starts from here, b squared, b cubed. So these patterns help us to find a formula for a plus b to the power of n. Suppose we study the patterns. Then we get a plus b to the power of 0 is 1, a plus b to the power of 1. We've written down only the coefficients. So a plus b, 1, 1, a plus b squared, a squared plus 2ab plus b squared, so 1, 2, 1, and so on. We write down all the coefficients. Now this particular diagram is such that it looks like a triangle, and it's called Pascal's triangle because he is the one who did a lot of work on these numbers. Now if you look at these numbers, you will find a lot of patterns, many patterns. The first pattern we see is that every term here outside is 1 and every term this side is 1. Then let's look at this set of elements, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Then we see that it's a very symmetrical triangle. That is, if you've got 1 and 3 here, here you've got 1 and 3. If you've got 1, 5, 10, 1, 5, 10. 1, 6, 15, 1, 6, 15. So it's very symmetrical on either side of the center line. Then there is still another interesting point. Suppose we add any 2. 1 plus 1 we get 2. 4 plus 6, 10. Any 2. 10 plus 5, 15. So which means that now I can even write a plus b to the power of 7 because I know it's going to start with 1. 1 plus 6 is 7. 6 plus 15, I write down the answer here, that is 21. 15 plus 20, 35. 20 plus 15, 35. 15 plus 16, 21. 6 plus 1, 7 and 1. I can write down the answer for any of these values. So this is a very interesting triangle and has many more properties. In fact, if you look at it closely, you will find that there are more patterns to this triangle.